Okay, so now let's jump to two sample hypothesis test. Okay, so we're going to do the example. Hopefully, you follow along utilizing the slideshow, and this is also in the book. It's chapter 6 through 9, uh, but I think that the PowerPoints are a little more helpful, right? So let's just use the example here, right? So the example is: do men and women significantly differ on their support of gun control? We have two samples: a sample for men and a sample for women. Uh, the same five-step rule applies that we use for a one-sample test. One is a sample size over 100. And for a two sample test, we simply just take the sum of the two samples, right? So for this particular sample, it is clearly over 100, right? It's 324 plus 317. That is clearly over 100, right? So then we move on to what type of test this is. So the wording again is: do men and women significantly differ on their support of gun control? The word differ means this, so it signifies that this is a two-tailed test, right? Okay, so we're going to be incorporating two steps in this process, all right? Were we given a alpha? No, we weren't given an alpha. If we weren't given an alpha, we use the 95% alpha, which equals us being wrong, or error of 5%, which also equals out to a z of 1.96. We can get that from the table in the appendix of the book, right? So this process has two steps, right? The first step is we need to determine the mean, the pool of the standard errors, right? And for a large sample, the the first step is the pool of the standard errors, which is this, and is equal to the following formula, right? The standard deviation squared of the first sample over n, the size of the first sample minus 1, plus the standard deviation squared of the second sample over its sample size minus 1. And the second step is, once we find this pool of standard errors, we go to z-obtain, and our z-obtain formula for a two sample is simply the mean of sample number 1 minus the mean of sample number 2 divided by the pool of standard errors, which we found up in our first step, right? Okay, so let's plug in what we got in this first sample, in this first example, right? So let's just use the first step in our formula, the pool of standard errors, right? So we know that the standard deviation of the first sample is 1.3. So it's 1.3 squared divided by 324 minus 1 plus the mean of the standard deviation squared of the second sample, which is 1.4 squared over 317 minus 1, right? So what we'll do here is we'll do everything inside the equation first, right? So we know that the square of 1.3, which is 1.3 times itself, is 1.69. And 324 minus 1 is 323. And we know that the square of 1.4 is 1.96 over 316. Now what we'll do is we'll divide each one of these by its denominator. So it's, for the first one, it's 1.69 divided by 323, which gives us 0.0052 plus 0.00 0.62, okay? And we'll take the square root of that, so that gives us a pool of standard error. After we add these together, we should get 0.0114, right? And we'll use our calculators to take the square root of that, and we should get 0.107, right? So we got 0.107 for our pool of standard errors, right? So the next thing we need to do is we need to plug that into our z-obtain formula, which is step 2. And we know that the mean of sample number 1 was 6.2. The mean of sample number 2 is 6.5, and we're gonna divide that by what we got in the first step, which is 0.107, right? So this is pretty straightforward, right? So all we got to do is 6.2 minus 6.5, right? And we get a negative number, so we get a negative 0.03, and we're going to divide that by 0.107, right? And that's going to give us a z obtained of negative 2.8, right? So what we do know is that if our z obtained is negative 2.8, we know this is a two-tailed test, right? Since we know it's a two-tailed test, we can put it into our normal curve, 0, and we know that this is our rejection region. We have a negative rejection region of 1.96 and a positive rejection region of 1.96, right? And we know that our z obtained is negative 2.08. It is definitely in the rejection region, so we will reject the null hypothesis. There is a statistically significant difference.